Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email with a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have some assets for our audience members today. We have an ebook and we have a white paper that's available for you to download in the assets section on your GoToWebinar control panel. The white paper is called A Guide to Key DevOps Metrics and Database Continuous Delivery, and the ebook is called How DevOps Can and Should Unlock the Database's Potential. Good stuff for you guys to access. One other thing, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. We also have a polling question today. I didn't want to forget that one. So please, hopefully we can get everybody engaged with that as well. All right, with that, let's go ahead and kick off today's webinar, which is Speed in CI/CD. Get faster to get better. Our speaker today is Dan Zentgraf, who's Director of Solutions Architecture at Liquibase. Hey, Dan, thanks for joining me today.
Well, thank you, Charlene, and thank you everybody else for sharing a chunk of your morning with us today.
All right, well, I know you've got a great presentation on tap. I'm gonna put myself on mute and let you get right to it.
Sounds good, I will dive in. All right, everybody, so as Charlene said, my name is Dan Zentgraf, Director of Solutions Architecture with a company called Liquibase, based out of Austin, Texas. We focus on CI/CD, particularly as it applies to database changes. And today in this presentation, I'm going to talk about speed. I mean, I've been involved in the Agile and DevOps movements for 15 years. And the entire time, one of the key things, if not the thing we talk about of why to do it, is speed. So I thought I would take some time and dive into that a little bit today and look at this whole notion, you know, this general concept that speed is good, but I'm going to assert that acceleration is better, and it's actually that bit about pushing to get faster and consistently pushing to get faster. That's what actually makes you better and eventually gives you the benefits of Agile and DevOps. So quickly diving in, because it is all about speed. Look, speed is good. You will have a hard time getting people to disagree with you about that. It is a key part of our culture as a community, as I would argue as a planet, right? And you don't have to be, just looking at these pictures, you don't have to be an aviation expert or a car nut to look at these pictures and say that, you know, the things on the left, they look fast, they look exotic, they are probably awesome. And the stuff on the right, perhaps a little less so. Perhaps practical might be a good word for them. But awesome is not likely something you're going to attach to them. And look, you know, we like speed, right? We like taking less time to get places. We like getting things sooner. Second day delivery is good. Next day delivery is better. Same day delivery is awesome. We don't like to wait. In fact, you see people get very frustrated when they're slowed down or blocked by something, particularly if it's not in their control. And as an aside, as I was putting these slides together, I was looking for cultural sayings on the benefits of speed, and there are gazillions of them, and they skew wildly to the positive. You can find a few cautionary ones in there, but they're few and far between when it comes right down to it. So, yeah, it is intrinsic to how we look at things. It's intrinsic to our culture. It's, you know, probably intrinsic to our species at some level. But we're here to talk about business, right? DevOps and CI/CD are, and most of us are in a business context. And you see this show up in everything, right? So this, for example, is a report that Gartner delivered a few weeks ago on an emerging technology roadmap for mid-sized enterprises. And they had this poll in there, which was, why are people investing in automation? And 76% came back with it improves speed and agility, right? What speed and agility actually means, don't know, but we want some of it, right? It immediately skews that way, and you can make the argument that the other 14% about productivity is probably a speed-related comment. So, you know, it shows up everywhere. It is part and parcel of what we do every day, and serves as this overall context that speed is good. But of course, we're here to talk about DevOps and in particular CI/CD. So we've got a quick poll for the audience. What do you think is the greatest benefit of CI/CD? All right, and Charlene's going to open up the poll for everybody to jump in and do their thing.
Yeah, poll should be on your screen now. What do you think is the greatest benefit of CI/CD? You can select from increased speed of delivery, shortened development cycle, increased release frequency, reduced complexity of dev lifecycle, and reduction in bugs post-deployment. Go ahead and make your selection. And while we are waiting for everybody to do that, just a quick reminder that we are taking questions from the audience at any time during the presentation. So you do not have to wait for the question and answer period before submitting your questions. Just use your GoToWebinar control panel and submit it at any time. And I'm gonna give you guys just about 5 more seconds, and then we'll close out the poll, take a look at the results. All right, closing it out now in 3, 2, 1. All right, let's take a look at those results. Looks like, wow, this is interesting. What do you think is the greatest benefit of CI/CD? We have a tie between increased speed of delivery and increased release frequency, which kind of makes a lot of sense, Dan.
Yeah, I mean, you know, to a certain extent, when we put this question in here, it's a little bit, yeah, we probably have an audience skew just based on the title of the webinar, right? But you know, the reason we did is that this actually matches my next slide, which goes to what people are looking for. The interesting thing is that reduced complexity actually came in as third.
Yeah.
So that's going to be interesting. We're actually going to talk about that in a later slide.
All right, I'll go ahead and, do you want me to hide the poll for you and get back? You can get back to your presentation now.
Yeah, because what we're actually going to do, well, yeah, because we're actually going to talk about the results here. So please do hide those, and we'll keep cranking here a little bit. So the reason we asked this particular, are we, sorry, I'm amped kind of moving forward here. But the reason we kind of asked this question is because of this report. So this was from the D-Zone Trend Report. And it's about the state of CI/CD in particular and the evolving, they're looking at pipeline maturity for the industry. And they were looking at this, and people could respond more than once to this particular survey, but we wanted to put this out here and see what the rank would be. You know, unsurprisingly, and this matches us, is that the top two, relatively close in our poll, was the increased release frequency and increased speed of delivery. What was interesting is that the shortened development cycle in our version of this was much shorter. We may skew to a DevOps/SRE community more than a dev community. So it'd be kind of interesting. But this is the point, and every one of these things that we see inevitably is, you know, why do we do CI/CD? Why do we do this speed? And it just keeps coming up. Well, here's the thing. We all know that speed is good. We've just spent a few minutes talking about that. But I would assert, and I've learned over the years, that really it's the acceleration piece that's better. Pursuing speed is better than just sort of keeping the speed you already have. As an example of what I mean, I'm going to take a look at the airline industry for just a bit. And in 1947, airliners looked like the thing on the left. They were big propeller-driven things. The engines were piston engines, and they would get around at a couple hundred miles an hour with decent range and pretty good reliability, especially for their day. was well-refined things. I mean, they even had beds on them. You weren't stuck. You didn't have to set your seat back. If you were in first class, you could actually go and have an actual berth. But there was a race on because we knew jet aviation was coming, and there was a whole bunch of companies trying to create the first commercially successful jet airliner. And Boeing succeeded in 1957 with the 707. And it's bigger, carries more people, and runs about 600 miles an hour. It's about 3 times faster than the plane from just 10 years before. In fact, you and I would recognize this as a modern airline. If you put a modern interior in one of these things, put us on without telling us what kind of plane we were getting on, it would be unrecognizable from modern airliners. And that's kind of where the punchline comes in. When you look at the actual speed of the Boeing product line over the last 60-something years, you find that it really hasn't changed all that much, right? Some are a little slower, some are a little faster, but they all run in about this range. And that has a lot to do with things like physics and aerodynamics, and really ultimately fuel economy, what the cost to run a plane and get from point A to point B with an aircraft is, and where it becomes economically efficient. So you look at that and say, okay, well, if you're an airline, no one can get people from point A to point B any faster than anybody else. There's no ability to differentiate on this in an economically viable way. And until the next revolution in aviation technology, here we are. Well, so why would you're going as fast as you can ever go? Well, that's not entirely true. So the standout from the crowd, the people who do things a little bit differently, is usually as a case study Southwest Airlines. Now, what Southwest said is, okay, well, you're absolutely right. Getting the planes from point A to point B is going to take as long as it does. Planes are planes. They're largely done. They actually use a pretty boring plane. It's been around forever, 50-something years with variations on the theme. But planes only make money while they're flying. They're only making money when they are taking people from point A to point B. While they're sitting on the ground, they're costing money. So how do we get faster on the ground? How do we gain more speed on the ground so that the planes are flying more often, right? So we're going to simplify what we do. We're going to standardize the plane. We're going to make it easy to move the crew around quickly. If we have to swap somebody out, everyone's certified on all the equipment, so we can move people around. If we have to pull somebody off another flight and then backfill them, we've bought ourselves time to do so. Same thing with the planes. Maintenance, keep spare parts closer to more of our locations. We don't keep the things for the 10 of plane, we've got 10 planes of a particular type. Think about typical airlines, we've got 10 planes of a particular type. We service them in one place. That's where all the spare parts are, and it's 3 time zones away. So if it breaks, well, everybody's waiting, right? Southwest also lightened the complexity of their boarding process, right? So they've got a much lighter process for getting people on and off planes. And it's interesting that that process of giving everybody a number, getting them in a line, telling them to get on the plane and sit down has proven to be a couple of minutes or more faster than everybody else's approaches, including the fancy algorithmic ones where they put people in a specific order that's supposed to be the most efficient way to board the plane. It's so famous it even shown up on popular TV shows. A few years ago, I think it was Mythbusters, did a study on that. They literally did the experiment. And for all of that, and for all of the ways they've optimized around this simpler, lighter process, adding automation for changing things out and making those things, making their scheduling system for planes and staff and everybody else flexible enough to leverage the simplicity and lightness of their processes, it's given them a competitive advantage, right? An investment in these improvements, seeking more speed, gave them a competitive advantage to the point where they are the only major US carrier that has been profitable on an annual basis for the last 47 years running. Of course, that's at the end of 2019, and 2020 is going to probably break this streak. But it's a great example of how somebody who's continuing to seek speed and finding ways to leverage their capabilities gains a business advantage, not just a technical one. So this is my point about pushing to get faster is what actually makes you better. So why then do we talk about speed instead of just getting better? Well, here's the thing. Speed, as I mentioned, culturally is something people are going to rally behind. It gives you a vision, a goal. It's aspirational, right? And undertaking a transformation is difficult. So you need something that's going to motivate people to take on the hard work because they want to be more awesome. Speed, faster things are more awesome. We want to be a faster thing. Second reason that we talk about it is that it serves as a proxy for continuous improvement. Gaining speed forces you to focus on what I call the other CI in CI/CD, the hidden CI in some respects, is continuous improvement. It's an intrinsic discipline underlying just about every Agile or DevOps practice out there. And this notion that you can improve, getting better results without backsliding someplace else, improving throughput while also improving quality, is what this is all about and what a lot of these practices prescribe. But speed is a lot more exciting and a lot more inspirational than continuous improvement, if you think about it. So this is a reason there. And since speed serves as such an effective proxy, why not? And ultimately, the other thing speed does for you is that it forces you to actually fix things. As you increase speed, you actually have to fix things. You can't ignore problems or band-aids or duct tape in your processes because that will break down as soon as you try and go faster, particularly if you go significantly faster. Right? So in the next set of slides, we're going to look at several things that are going to happen simply by pursuing speed and continuing to pursue speed. These are things that are going to improve in your world. And we'll start off with some basic ones, look at some related to controlling things, and then finally the last two are really more about optimizing once you've achieved significant speed. So the first thing that happens as you start to try and go faster is you realize that what you're doing today is probably too complex to accelerate. There are gaps. And you go and you work, I get to work with customer teams and talk to them about their processes a lot, and you find situations that there will be parts of the stack in any given pipeline that are very optimized. Usually it's the app code, but then there are other parts that are less optimized. They have manual processes, tickets, a lot of handoffs, a lot of things going on, and you figure out pretty quickly that the company is managing two or maybe even more distinct processes and bearing all the management and maintenance for those two distinct processes. Further, there's usually a third process hidden with the cost sort of leached out of the other two, which goes to how much time gets wasted coordinating, synchronizing the two disparate processes, making all the little adjustments and corrections that go wrong because the processes are so different. They've just got all this extra complexity that they have to manage just to keep things together and get the changes from point A to point B as part of a unified stack. Ultimately, what people are trying to do is get to this, right? This is where everybody is going to end up, is unifying the process so there's one basic workflow for everything. There may be different tooling, right? So you've got different tools that plug in for different pieces of the stack, but you have one workflow for all the changes. It's something that's easy for people to learn and communicate about. Whether you're a new hire, you've been there a while, everyone's got a common lingo because everything goes through the same basic workflow. It's easier to manage. You've got a place where you can unify information about progress and the source of the truth and information about how things are going. And that's all well and good, right? We want to start simplifying our processes, but then comes the thing that, well, the processes we're trying to simplify are individually very heavyweight. So just take this example here. This is actually some work we're doing with the company, and this is their database change process. This isn't nothing to do with their applications, really. This is just the database layer, that bottom pipe from my from a couple of slides ago. This is their version of that. There are 3 different ticketing systems, a whole bunch of handoffs. One of the people they're equipped that they have more handoffs in their process than you would see in an average NFL game. But you know, there you go. You've got this heavyweight process with a lot of manual checks, balances, tweaks, all the adjustments and things just to keep things flowing and have a hope of synchronizing with what the applications team are doing. It's a very heavyweight process, very classical, bureaucratic, and it, you know, it's kind of an elephant that you're trying to carry up a hill as fast as you can. That doesn't really, that's a really hard thing to do as you try and improve and get faster. What you really want is something more on the order of a mouse, perhaps a house cat. Where you get to, and this is the counter example, so when we were working with them, this was where we took them, is how do we get them to a simpler, lighter weight process, something that has cleaned communications paths. You get a single source of truth for things. When artifacts are created, they don't get copy pasted into tickets or attached to tickets. They don't have to be manually pasted someplace to deploy them. You can bring in the changes through a single flow, still meets their governance requirements. There's still more optimization that they can gain from this, to be fair, but smooths the flow, makes it easier, and as they seek to optimize and improve the flow through here, it's going to be much easier for them to do than the beast that preceded it. So once you've simplified the process, you've got things kind of unified, you start taking weight out of the individual piece parts of it, make it lighter, make it easier to deal with. The next thing that you do is start adding automation seriously and start getting a continuous flow going. Automation is the fastest way to go fast, but even though it ensures predictable results, it also will not tolerate an inconsistent process. So as you simplify your process, as you lighten the individual piece parts, the automation will expose where you're inconsistent there, where you've got exceptions that you don't need. Too many exceptions and special cases will just flat kill you. You won't be able to gain the speed or the benefit from the automation. So as you push to go faster, if you really want the speed, you will be forced to standardize what you do. You're going to have to decide what is or is not acceptable input without discussion. It's part of that, one of the forcing factors for shift left, because at the end of the day, garbage in, garbage out is just amplified by automation. If you have bad inputs, the automation will process them and give you a whole bunch of bad outputs. And if you're trying to go fast, you don't have time to deal with all of that garbage. So you're going to have to make some decisions, and you're going to have to fundamentally fix what you view as exceptions. It creates pressure into the system to actually make things better. And when you do, you achieve a flow like this. All pieces of the, this is the vision I talked about. Everything goes through the same workflow. There's an easy flow from left to right. Everything goes into a relatively well understood set of repositories for source. They get processed through a validation process, right? So you get your app code, infrastructure as code, database changes as code. Everything gets validated before it ever goes into the main pipeline, and only groups that have validated together get moved into the rest of the pipeline for subsequent consistent deployment on out as you qualify those changes as production grade or not. Individual pieces of the stack have specific tooling, but all of those tools are brought together and work in unified harmony, whether it's a security tool, an infrastructure tool, vaults for credentials, or of course your database change management tool. Everything hangs together and lets you run automated from end to end. So with simplifying things, lightening things, and automating things, you get that basic rhythm going, right? This is good. You achieve a pretty good amount of speed just doing that. But once you get to a certain point with speed, you kind of hit a plateau because things are starting to happen faster than humans can really watch, right? The automated processors are very good at doing things. They're moving as quick as they can, but now the bottleneck is the fact that it's just going faster than you can manage with how you're currently handling the automation, right? Humans can't keep up. So you have to add a level of monitoring and instrumentation to what's going on here. You need to establish what is a normal set of activities. The individual automation tools in your pipeline will or should be reporting good activity, what they've done when they're doing it, and what the outcomes are. And you get a big pile of data there, but what they can't do is thread together what's in bounds, what's normal. When you do make a tweak to one piece of the stack, did that give you a net improvement? Or does it need further fine tuning, or did it go the wrong way and you have to fix it? This kind of decision support and visibility is the next thing you're going to have to adopt or adapt into your environment to take the next stage and go that much faster. For example, right, so we are, I work with Liquibase. We're a tool in the stack, and this is an example of how we report our information up, right? We just went on Monday, we shipped a beta of a product we call Hub, which is a SaaS offering, and all of the data from your Liquibase clients gets reported up to the Hub, key events, and along with results, timestamps, and so forth, so that you can track what's going on and then integrate this with broader monitoring tools elsewhere in your organization. All about being a good citizen for the changes in the overall flow. Keep your pipeline so you can see what's going on. Now, once you're doing that, that's good. You get control, and now you can go a little bit faster and you gain additional speed. The other thing that you're going to start looking at is, well, I'm accumulating all of this monitoring data. I've got good metrics about what's going on in my process coherently through the whole stack for the first time. And now I can start really looking at the bigger outcomes, the bigger business outcomes, and are things all going and head in the right direction? And the good news here is that you don't have to invent the wheel, right? The folks from Dora, Dr. Forsgren and friends, have put together they wrote a book a couple of years ago called Accelerate. It explains exactly how and why you should do it and precisely what you should measure as the trend lines over time, which is your lead time, deployment frequency, change failure percentage, and mean time to restore service that fails. And they've done all the research for precisely why those are the most valuable metrics for you to do it. So you can kind of read the book, do what it says, and you've got the best practice until the next revolution in how we do things really comes to pass. Of course, this is sort of a real world example. One of the things I will point out is that improvement is continuous. Even as you're pushing for speed, it's a proxy for continuous improvement, but it is nonetheless a journey. This is some work from one of our customers, and the sharp-eyed among you will notice that, well, 3 of the metrics are represented, but the 4th is WIP production, which is a great measurement for deployment throughput, but it's different to what Dora prescribes. And this is sort of evidence of where they are on their journey. The team we're working with is responsible for the deployments. They're not responsible for uptime, so they track it a little bit differently. So they're working on it. They know, but this is a classic example of continuous improvement is truly continuous, and you're never quite done with the journey. Which brings us to our last 2 points here, and that is that once you've achieved this speed, you've got things fully automated, and you're monitoring, things are healthy, and you can tune it and make it go ever faster. Well, your ability to tune it becomes increasingly important. You have to start doing the engineering to make sure that you can make your adjustments at a very fine-grained level. And this is important because you want to avoid large swerves, right? Because small errors, small changes compound very quickly at speed. So you want to be able to constantly adjust towards your expected outcomes, towards those trend lines, but you don't want to make a radical adjustment, or if you do make an adjustment, you want to be absolutely sure you understand the likeliest impacts of that. Think about it this way. You can imagine the types of inputs you need on your steering wheel at your car. If you're driving your car 120 miles an hour down the road, you're probably not going to jerk the steering wheel around too terribly much. You're going to keep it in your lane and in a straight line, and not make any large twists of the wheel. Meanwhile, at 10 miles an hour trying to get into a parking space, you're cranking the wheel left and right, trying to slot your car in between two giant SUVs. So it does come up, and speed brings you to this level of understanding of your process to where you can do this sort of thing, because frankly, you have to. Right, and so for example, every tool in the stack ends up having to do something like this, where you've got a visualization of where all of the changes are. You've got the ability to track individual changes and see where things are moving. If anything is not moving together or moving how it should, you can make the adjustments. There can be no laggards. There can only be, everything has to go with the release, and nothing can fall out of the release unless you explicitly remove it. And all this is about driving out rework from the process. So you can go fast and still tolerate an error rate, but at some point, your optimization will take you to the point where it's all about getting things through first time, complete, and accurate. This is why when you hear discussions from high-end digital native, cloud native type companies of why they, how they get things deployed every couple of minutes and very short lead times through their pipelines, they've gotten to this level of optimization where they've got a high degree of confidence that changes come through first time, complete, and accurate. They have built quality in. They're using the pipeline tools and capabilities. They have to ensure everything, any problems are caught quickly, and they've optimized those flows to avoid disruption. If something does come through, they've got a good way to get it out of the way. Because if you think about it, any kind of a flow disruption is going to bottleneck your process pretty quickly. You've got a bunch of things downstream waiting for that change to arrive potentially, and you've certainly got things sitting behind it waiting to be processed that also have dependencies that may not be able to advance until everything gets going. So one disruption, it's not just the one or two people working on that particular problem change, right? It cascades to your whole organization potentially, or a large chunk of it. And that's just costly and frustrating. And people hate it when their work is blocked by things they can't control. So driving for speed is going to drive you for that. And the great news is that there are a ton of tools out there for doing this in various levels of maturity and advanced features and so on and so forth. And you'll bring these things on in your automation phase, but you're going to start really optimizing and using their advanced features here, and all the tools in your tool chain that drive your stack forward have to fit nicely into that. For example, we've got a variety of ways that we plug in here. It's part of what drives us forward to serve our customers, and it's all about enabling our customers, wherever they are in their journey, whether it's at the basics where they're simplifying, lightening, and automating, whether we're helping them monitor and track things over time, or fine-tune their processes and optimize at the most mature end. Right. This is how we respond. And so we see across the board that as our customers push for speed and push to advance, is where they really see the noticeable improvements in their overall outcomes. All righty. So with that, I'm at the end of my prepared comments for the session here. Want to go ahead and open the floor up for questions. I think Charlene's going to have some instructions for us in that vein. And before I turn over to you, Charlene, just real quick, I want to invite everybody on the call Liquibase is an open source based project. Please join our community. Come participate. If you'd like to talk to me after this, my email address is right up here on the slide. All righty, over to you, Charlene.
All right, great. Thanks, Dan. Yes, we have lots of time for question and answer period. So go ahead and use your GoToWebinar control panel and submit any questions that you have. We've already gotten a couple in, so let's go ahead and dive right on in. Here's the first one for you, Dan. How can we achieve CI/CD or DevOps methodology in small organizations?
Well, so the first thing I would say is, make sure that you start with a goal, right? I mean, so part of the reason that speed is so popular is it provides a goal that you can rally people behind. So start with the goal and then look at your process. So remember that the first two things I presented, first 2 points, were about simplifying and lightening and automating your existing processes. First part of that is understanding what those existing processes really are and which ones you're going to focus on, because they're generally the most problematic. One of the rules of thumb for CI/CD and DevOps is to start with the hardest thing first, right? Solve that problem first, and then the rest start rolling. So you have to do that. You really do have to do some level of that analysis to get yourself going in the process. And from there, as you start seeing the benefits, it will roll. But all good journeys in CI/CD and anywhere start with a good problem statement, right? Somebody famous, and I forget who, once said that the biggest portion of solving a problem is defining it. So start there, and you'll find the support for it, at least within the team at the grassroots, and you can move up from there.
All right, great. Gotten so many great questions, and here's the next one for you. Let's see, how is Liquibase going to help in CI/CD?
So, as we are a role player, so we focus on the database, the persistence layer of the application stack. And so our job is to enable people to bridge the gap between their CI/CD type processes, help with that simplifying and unification phase of the conversation, right? We actually start right there, is bridging the gap into database technologies. Databases are a very different kind of animal than app code, right? So app code, you sort of have a build, and if you don't like the result of that build, you can throw away that binary and get make a new one that you maybe like better. Well, databases are stateful, right? I mean, the changes you put in there are sticky. So if you want to be able to process changes through in any kind of an automated fashion to make it match the workflow, because it's an as code definition, right? How do you leverage that? You need specific tooling to do that. And so our job at Liquibase with all of our products is to help our customers meet them where they are on their journey and then bridge the gaps into that tooling. And then it gets very case by case for the best way to do that, obviously. But the general principle is the same regardless of which of our products you engage with, is bridge the gap, bring it in, and allow you to have that as code flow with a managed set of changes going through the pipeline from start to finish.
Excellent. All right. Next question here. What are the tools you have used to streamline CI/CD?
So I've been at it a while. I actually got involved with automation tools when all we had was CI. We hadn't. We didn't have CD yet. We just called it the deployment thing that happened after the build. Right?
CD sounds so much better now.
Yeah, it really does. I tell you,
It's got a ring to it.
Well, yeah, when the buzzwords turned up, right? I mean, 2009, we got the DevOps buzzword. It was magical. Because we actually could put a label on what we were talking about. So I've seen kind of all the tools come and go, right? I can tell you my first CI server was cruise control. I've been involved with a lot of commercial solutions over the years, BuildForge and you know, the Urban Code, the commercial enterprise ones, Jenkins, you know, Circle CI, Travis CI. I can kind of go on for the big orchestrators, and then the individual tools come and go for pieces of the stack. You know, so you can look at for infrastructure stuff like HashiCorp. The cloud providers all have, you know, Amazon, Azure, for example, have great stuff for infrastructure as code. You know, Chef it is still pretty effective if you're in that, if you're in the VM world, and then all the security scanners and code scanners so that you can build the quality in. You sort of have to figure out where you are and what part of the pipeline. There are so many tools, to be fair, that you end up having to integrate and work with, and at different points in time to optimize your flow. It is one of the bigger challenges, I think, for people working in this space. And as you know, we start talking about it as an overall discipline to bring ruggedness and health into the applications we're running in production. Yeah, there's a lot.
Yeah.
I don't know that there's a tight list there.
Well, I think a lot of it a lot of it depends on a number of different factors, right? I mean, you know, between the tools in the pipeline in general and the individual workflows and how organizations work, and there's a lot of different factors.
There's so many variables. I mean, from, you know, I mean, just look at it. The variance in tools, if you're running Java on a classic app server versus Java, you know, in a containerized microservices architecture in Kubernetes, right?
Mm-hmm.
Yeah, it wildly different, even though nominally the tech stack looks similar.
Mm-hmm. Mm-hmm. Okay. All right. Well, we've gotten so many great questions in, but guys, there's still plenty of time. So if you have a question for Dan, please go ahead and use your GoToWebinar control panel. Here's our next question. How do we bring CI/CD culture or mindset to an organization that is recently trying to adopt it?
So the first thing I will say is the cop out on is education, right? Spend the time to educate people on not just how you're trying to do it, right? Don't just teach them how to use the tool, but teach them why the tool helps.
Mm-hmm.
You know, for people to really understand, you know, why we're using this tool. It's a lot easier for them to make the shift a lot of times than if you just say, hey, we're using this new tool. It's going to make you go fast. Yay, because fast is good, right? Well, one of the things about that is you find is that just because you give somebody that capability doesn't necessarily mean they feel that motivation to do it, right? It's like, yeah, it's not personal to them. So take the time, educate them on the why and how it all fits together. Make them a part of that. Remember that, and this is why so many DevOps and Agile conversations always come back to culture. Is, you know, understand where people are coming from, listen to them, educate them on not just why it's going to be better for them, but why it's going to be better for the whole company, what you're trying to do. Give them some context that they can buy into, and how, you know, together we're all going to be fast, we're all going to be awesome, you're going to be awesome, yeah, we're going to have all these benefits coming in. But you actually do have to take the time. Simply, DevOps is not something you can go and get, right? You have to go and, you know, you definitely have to bring in technology to help you do it, but it's a lot about that cultural mind shift, and really having the empathy and sharing with people of, you know, why and how this is working, and bringing them along through the journey with you. There's no there's no magic bullet, unfortunately.
Right, right. Okay. All right, great. Here's our next question. Let's see. On the DB inclusion and CI/CD process, have you seen Delphix mentioned in the? Oh, I've seen Delphix mentioned in the diagram. Can you elaborate a bit more on how it is achieved Do you take a snapshot and build on it, or have a clean new database created and run scripts?
Right, so great question. So one of the things in the diagram, the slide you're talking about, is there's actually a whole bunch of different tools mentioned. And each tool sort of plays a role and plays a part in the stack. Everything manages their piece of it. So whereas Liquibase is so much about database change management, dealing with the structural and some seed data and some the scripts and stuff, making sure the right versions of all of those things, the right schema and structure are in any given target database. Delphix, on the other hand, has tools for resetting those environments. So if you want aggressive testing in a particular environment, you have the ability to very quickly reset it with a Delphix snapshot. I forget their specific term for it, but it's a big chunk of what they do is to get you to a known baseline very quickly, and then we integrate with them. We've got a real smart and symbiotic relationship with how they work to bring the structure up to what's expected for the inbound features. So they may snapshot back to last Friday's database, and we've actually got two or three new features to bring in, because it's Wednesday, and we want to add those back in, and we just automatically will do that so that you reset and can now rerun your test cycle. It's all about speeding up your cycle time in test environments. Delphix also is the part that deals with large scale test data, right? So they can bring that production quality masked, obfuscated data sets into those test environments. Again, where we interact with the most is fast cycling environments. You can do very aggressive tests and always start the tests at a known baseline, right? So even if you change data or do other things to the database as part of your test cycle, you're always starting from a known clean starting point, and you would have one test run contaminating the next. So that's the relationship there.
Okay. All right, great. Next question here. Our developers use Liquibase. Can we use that in the rest of our pipeline?
Absolutely. that was a big chunk of what we've been talking about here is CI/CD and Liquibase fits into the whole run of it. Your developers have really done you a favor there, because what we do is you're defining your database changes in a structured way. There's actually a client-side file we call a change log that defines what changes are being applied in what order, and you can put that in source code and then consume that and versions of that, more importantly, through the rest of your pipeline, and use Liquibase to do those deployments into your progressive, your validation environments, and even we've got a lot of customers that will use it on into production. And so absolutely, so your developers have already taken a big step there for helping you create a more optimized pipeline, because they are already using it to create those structured groups of changes. So absolutely, thank them and find good ways to consume what they're doing.
All right. Buy them lunch or something. I don't know.
Right.
All right.
When you figure it out, you'll be very happy they did.
All right. Okay, great. Next question here. Let's see. How does this relate to value stream mapping? That's a good question.
Well, yeah. So value stream mapping, as I mentioned in one of the earlier questions, is about getting your arms around the problem. And part of it is understanding where you are, is being able to define that problem and find where the biggest value points are to hit. Value stream mapping is a technique for doing that. And it focuses on where you're doing work in a process, and where you're doing work, where that work adds value, where it is just necessary, and also very importantly, where things are just waiting, where things are just paused in between steps, so you can identify where the big bottlenecks are in the flow and work on them. It's like, where do I start? Well, get your arms around it, put some, value stream mapping is one technique for doing that. It will help find the big bottlenecks, things that are going to be most beneficial, hopefully a quick win, maybe a little harder, kind of start with the hardest thing first, and work on, give you a good target list for what that is. So value stream mapping is a technique for getting your arms around the overall design and figuring out where to optimize. It's not, it's a tool and a technique unto itself. It's not directly part of the CI/CD process.
All right, so we are about 10 minutes to the top of the hour. I think we have time for a few more questions here. How do we speed up continuous testing and feedbacks in CI/CD?
Man, people are asking the big thoughty question.
Well, you asked for them, right?
Right? Yeah, no, that's what we're here for. Look, ultimately, with testing frameworks, you've got a lot of every application requires a different testing discipline, and it'll be dictated by the nature of the application, its architecture, and so on. Ultimately, being smart about how you define those tests and wrap automation and around them is is a whole design conversation unto itself. But doing that so that you create just enough testing without overbaking it. So I've seen people adopt testing and try and automate it, and they end up freezing. They stagnate because they're spending all of their time developing tests and not enough time actually moving the code stream forward. So I'd kind of recommend that you go in and kind of investigate that. With the eye toward, CI/CD, what you're looking for there is to have those test frameworks produce data that you can subsequently consume, and putting the monitoring around the test data that comes back. Spend the time engineering something to take in that test data and identify hotspots and do some of those things, because that will help shorten the feedback loop, or at least make the test results more actionable to the people receiving it, and that starts shaving time out of that cycle. But it becomes very specific very quickly.
Excellent. Okay. I think we have time for one more question, then we'll go ahead and close out the question and answer period since we've been doing so many of them. Let's see. Okay, here's a good one. There's internal buy-in at my company to quote unquote go fast, but we don't know where to start. So what are your thoughts?
Yeah, it's a bit of a rehash of the first one. Honestly, I always start with, I always say, okay, guys, before we go and invest a whole bunch of time fixing something, let's make sure we know what's broken first. And, this goes back to defining the problem, doing that. Part of the reason we do some of those big, hairy process diagrams with our customers is to actually help them understand their own processes. We've done an awful large number of those, and I can't tell you the number of times I've had people tell me, that's the first time I've ever put the end-to-end process in one place on a whiteboard or in one document, right? Because everyone sort of knows their sliver of it, and we get everybody together and say, okay, guys, let's draw this end-to-end. And just that exercise, that's why value stream mapping, for example, is such a popular technique for DevOps and CI/CD in particular, as a technique for teasing that information out, getting a handle on what's going on. And so then you can then really focus in on the things that are going to bring you the biggest value, right? So you get end-to-end automation, but where do you really focus? What are the hard things that you're going to have to really deal with to make that work the way it needs to get the speed you're looking for? And like I said, speed's going to force you to make some hard decisions and identify problems and fix them. And that is a great example right there.
All right. Well, we're just about 5 minutes to the top of the hour. So I'm going to go ahead and close out the question and answer period. I do want to remind the audience that there are 2 assets there in the Assets tab that you're welcome to download, an ebook and a white paper. And as you can see on the screen, we do have a couple links for you as well, places where you can go to see Liquid Base in action. So please be sure, and I think Jade has actually messaged that out to the audience as well, those links. So please take note of them. Want to quickly remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, at the top of the hour, I did note that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is Arthur M. Congratulations, Arthur. Next winner today is Jeff K. Congratulations, Jeff. Our third winner today is, let's see here, Phil W. Congratulations, Phil. And our final winner today is William S. Congratulations, William. And congratulations to all 4 of you. We'll be following up with you offline by email to get your gift card over to you. So please check your inbox. If you don't see it there, please check your spam folder. Dan, thanks so much for your time. Great presentation, lots of great information. I know, judging from the quality of the questions that came in, the audience got a lot out of it too. So thank you again for your expertise. Really appreciate it.
Well, thank you, Charlene, and thanks again to everybody in the audience for your time and attention this morning.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm now signing off. Have a great day, everybody. Please stay safe.